All right, and number 8, we're trying to isolate trig functions to solve for x in trig equations, but I've got 2 different trig equations here. I've got cosine and sine. So I'm not going to be able to isolate one and solve. I'm not going to be able to do any factoring because there's not going to be a GCF or a quadratic form with like a cosine squared and a cosine. These are 2 different trig functions. So you have to remember back to your identities and see if we can replace something. Okay, so first, let's start off by moving a constant. Notice if I move that constant, either one that I started with, I would have to add it to get to the other side. That leaves both sides as 0 for the constant. They cancel out completely. So we've got cosine of x equal to sine of x. So you can use identities to go through this and try to replace one or the other and go through a little bit of work, but really you've just isolated both. This question is simply asking, where are sine and cosine equal? So think about your unit circle. Where are the x and the y value, because cosine corresponds to the x and sine corresponds to the y around the unit circle ordered pairs. Is there a place around the unit circle where those are identical, where they're equal? And there is. And you can pull out your unit circle if you don't know it in your head. You're looking for where are they exactly the same. And that happens here at 45 degrees. They're both root 2 over 2. But it doesn't happen at every 45-degree reference angle, because like here in quadrant 2, one's negative, one's positive. And in 4, one's positive, one's negative. But here, they're the same. They're both negative. And here they're the same. They're both positive. So it's at those 2 angles, pi fourths and at 5 pi fourths. And if you need to sketch out on your work, if you want to show that, you can. But these are the 2 locations where the cosine and the sine, the x and the y, are identical. So your answer is 5 fourths and 5 pi fourths. Excuse me.